Okay, hello guys. So in this video we are going to keep talking about equations in quadratic forms. So I remind you that the goal is to rewrite each of those equations that are not quadratics in terms of a quadratic equation by using a simple substitution. We solve the quadratic equation, and then once we find the solution, we come back to the original substitution and we solve for the variable of the problem. And you should try to work this problem by yourself first, and then check your understanding with the process I'm going to show you. Okay, so let's take a look at this problem number 2. So I want to solve for t, and written this way it looks actually very complicated. We cannot isolate t, so we're going to use the quadratic form, which means we're going to rewrite these equations in terms of a y squared plus by plus c equals 0. Now, to go from this form to the quadratic equation equal to 0, we need to make sure we set up this equation on the left side equal to 0. So we're going to add 7t to the power of 1/3 on both sides, and we're going to subtract 15 on both sides. So what we are, so when we rewrite that, we have a 2 to the power of 2/3 plus 7t to the power of 1/3, and then we get minus 15 equal to 0. Okay? Alright, so now we're going to compare with the quadratic form. What do you think is going to be the value of c? Well, c is the number by itself, so it's going to be this negative 15. And then 7 would be the value of b, because we have a t to the power of 1/3, and then t to the power of 2/3 will be your y squared, so these two represent the a part. Okay? So let's rewrite this now in quadratic form. So what we get is a we know is going to be 2. Well, let me make a substitution first. The substitution, so the value of y is going to be, the term of y is going to be the term next to 7, because this is the b. So y is going to be equal to t to the power of 1/3. Okay, so it's going to be all of this. So this is your y, right? You have by, right? And this is going to be your y squared. So now we have ay squared plus by plus c equal to 0, right? Which in our case is going to be 2y squared, b is 7, so plus 7y, and then minus 15 equal to 0. So at this point we need to solve this quadratic equation in y. Once we find the values, the two values for y, we plug it in back into this original substitution, and we can solve for t. So this is the process. Alright, so in order to do that, well, can we factor this? Let's see, can we find two numbers whose product is negative 30 and whose sum is 7? Do we know these two numbers? Okay, well, let's see, we can use, if we think of the factors of 30, well, we can start from 1 times 30 cannot work, and then we can try with 2, and this would be 2 times 15, we cannot use this number, and then we can try with 3, and we get 3 times 10, which is 30, right? Now one of the two needs to be negative. In particular, we're going to have a negative 3, because we need to get a positive 7 as a sum. So the two numbers are negative 3 and positive 10. Which means I cannot use the shortcut because there is a 2 in front, so we rewrite this as 2y squared plus 10y minus 3y, and then minus 15 equal to 0. So now we pick up the first two terms with the greatest common factor of 2y, so we write in parentheses y plus 5, and then the last two have a greatest common factor of negative 3, and again we write in parentheses y plus 5, and we set up this equal to 0. So now we have a greatest common factor, which is y plus 5, and we are left with 2y minus 3 equal to 0. So we need to solve each of those equations, which means we need to solve y plus 5 equals 0 or 2y minus 3 equal to 0. And the solution from the first equation is clearly y equal negative 5. For the second one, we have 3, we divide by 2, so we end up with y equal to 3 over 2. Alright, so now that we found the value of y, we are not done. We are going to come back to this original substitution, y equal t to the power of 1/3. So since y is equal to negative 5, this means that t to the power of 1/3 needs to be equal to negative 5. And we can solve this by taking the cube on both sides. So we cube this, we cube negative 5, so 3 times 1/3 is 1, so we get rid of this, and we are left with t, which is equal to negative 5 cubed, which means negative 5 multiplied by itself, so multiply by negative 5, and then multiply by negative 5 for a third time. Negative 5 times negative 5 is positive 25. Positive 25 times negative 5 is negative 125. And then for the second one, y is equal to 3/2. It means that t to the power of 1/3 is equal to 3/2. We take again the cube on both sides, and then this will simplify to t, and then what's 3/2 to the power of 3? Well, if we take the third power of the numerator, 3 to the power of 3 is 27. And then if we take the third power of the denominator, 2 to the power of 3 is 8. So t is 27 over 8. So now we are done. And we can write the solution set, which is given by these two possible values for t. One is negative 125, and the other value for t is 27 divided by 8. Okay. Alright, so let's go to problem number 3. Okay, so again, our goal is to rewrite this equation in terms of a y squared plus b times y plus c equals 0. Start with c. C is usually the easier to identify as the number by itself, so that's our c. B will be the negative 7, and a will be 1. There is a hidden 1 here, so this is our a, right? So I should write here b instead of negative 7. So that's b. Okay? And therefore, the y is the term next to negative 7, next to b, which is this one. So this helps us out with our substitution. We know that our y must be 2x plus 5, and therefore this term is going to represent the y squared, right? So now we have that y is equal to 2x plus 5, and we can rewrite this in quadratic form. So in quadratic form, this becomes 1y squared, which is just y squared, minus 7 times y minus 30 equal to 0. Can we factor this? Can we find two numbers whose product is negative 30 and whose sum is negative 7? And again, we're going to use 10 and 3, so positive, well, it should be negative 10 and positive 3. And we can use the shortcut because the value of a is equal 1, so we can use the shortcut. I write this as y minus 10 times y plus 3 equal to 0, from which we can get the two possible solutions. So y minus 10 equals 0, or y plus 3 equals 0. So the first one gives us y equal 10, and the second one gives us y equal to negative 3. And now we know that y is 2x plus 5, so we just have a 2x plus 5 equal to 10, or y equal negative 3 means I should write 2x plus 5, so we have 2x plus 5 equal to negative 3, and we can solve for x. So let's subtract 5 from the first one, and we end up with 2x equal to 5. And for the second one, we get 2x equal to negative 8. And then from here, we get x equal to 5 over 2. And from here, we get x equal to -4. So interestingly, we get only two solutions, and the reason is that this is actually a quadratic equation, if you notice, because here we have 2x. When we square it, we get we get that the highest exponent is going to be a 2. So it's a quadratic equation. In fact, we could have solved this particular example in a different way. We could have taken the square root of 2x plus 5, subtract the 7 times 2x plus 5, right, and write an equation in terms of ax squared plus bx plus c, right, equal to 0. We could have just solved this one for x. We would have got from here 5 over 2 and -4, okay? So, of course, the a, b, and c in this equation I just wrote, they are not the same of a, b, and c we have here in red, okay? This would be three different coefficients that come up as soon as you take the square root of 2x plus 5, and then you combine the terms, okay? But we could have done this differently, this specific example. I still think that using a quadratic form makes this process a little bit shorter, okay? Alright, so here is a problem a little bit more challenging, and it would be interesting to see if you guys can try to figure out what's the y here. I think it's a little bit challenging to do the right substitution, and once you do the right substitution, then you can solve. So we want to solve for n. Be careful, because that's not a quadratic equation. This is actually a rational equation, because n is at the denominator, okay? Our unknown term is at the denominator. Alright, so you should try to do this by yourself and see if you can at least identify the value of y. Once we do that, the rest is standard, okay? Alright, so we want to write this in the terms of ay squared plus by plus c equals 0. Now notice first of all that here we have equal 5, so we need to subtract 5 from both sides. So we have 2 divided by n plus 2 squared minus 3 divided by n plus 2, and then we subtract 5, and then we have equal to 0, okay? So what do you think is going to be the value of c? Well, clearly the value of c is -5. Now the question is, what do you think is the value of b? And I don't know if you know this, but the value of b will be this -3, only -3, okay? In fact, we can, let me rewrite this a little bit different. Instead of 2 over n plus 2 divided by n plus 2 squared, do you agree that this is the same thing of 2 times 1 over n plus 2 squared? It's the same thing, right? Instead to write -3 divided by n plus 2, we can rewrite this as -3 times, so -3 times 1 over n plus 2, and then this -5 is by itself equal to 0. So clearly the value of c must be this -5, and then from here you should see that the value of b is this -3, and the value of a is this +2. Now that I a little bit separated this from the term next to them. So what do you think is going to be y? Y is the term next to -3, which is 1 over n plus 2, and therefore this must be y squared, right? So now we have ay squared plus by plus c equal to 0, right? So let's rewrite this in terms of a, b, and c that are given to us. So we know that a is 2, and then we have 2y squared. We know that b is -3, so -3y, and then -5 is by itself, that's the c term, and this must be equal to 0, okay? Alright, so let's solve this equation. We need to find two numbers whose product is -10, whose sum is -3, and these two terms must be, these two numbers must be -5 and +2. We cannot use the shortcut because the value of a is a 2, so it's different than 1, so we should rewrite this as a 2y squared, and then we have instead of to write a -3y, we're going to rewrite this as -5y plus 2y, and then -5 equal to 0. And then let's group the first two terms. The greatest common factor of y that multiplies 2y minus 5. If you look at the last two, the greatest common factor is just 1. They multiply 2y minus 5 equal to 0. So now we have a greater common factor of 2y minus 5, so we end up with 2y minus 5 times y plus 1 equals 0. So, which means that we want 2y plus 5 to be equal to 0, or y plus 1 to be equal to 0, from which we can solve for y, subtract 5 and divide by 2, we end up with a negative 5 over 2, and then from this one we get y equal to negative 1. Okay? Alright, so at this point we need to come back to our substitution. So the y is equal to 1 over n plus 2. Okay, so that's our substitution, right? Which means that this now I need to rewrite in terms of n. So instead of y, I'm going to put 1 over n plus 2 equal to negative 5 over 2. And now we're going to try to solve this for n. And then for the second one, this y is 1 over n plus 2. And this is equal to negative 1. Okay? Alright, so let's start to solve this one. 1 over n plus 2 equal negative 5 over 2. We can cross multiply, right? So in order to make sure that you don't get confused the way I wrote it down, let's rewrite this as negative 5 over 2 in this way. So you know when you cross multiply, you need to multiply 1 by 2, and then this negative 5 with n plus 2. Okay, so what we get from here, we get 2, 1 times 2 is 2, on the left hand side, equal to negative 5 times n plus 2, which means that 2 is equal to negative 5n minus 10. We can add up a 10 on both sides, or actually, well, yes, we can do that. Negative 5n equal to 10 plus 2 is 12, so n end up to be negative 12 divided by 5. So that's one solution. And now, in order to find the other solution, we do the same thing here. Let's cross multiply. Negative 1 means negative 1 over 1, from which we get 1 equal to negative 1 times n plus 2, which means 1 equal to negative n minus 2, and therefore negative n is equal to 2 plus 1, which is 3, so n equal to negative 3. Okay, so our solution set is equal to, okay, it's not working here, so solution set is equal to, so we found these two solutions. One is negative 12 divided by 5, and the other one is negative 3, so we got the two solutions. Okay, all right. Now keep in mind that this problem makes sense as long as n is different than negative 2, because if n is equal to negative 2, the denominator becomes equal to 0, and this form becomes undefined. But we didn't find the negative 2 as a solution. If we did, we should have excluded that solution, but we didn't, so we know that negative 12 over 5 and negative 3 are going to work. Okay? Now, for the next problems, I'm not going to solve them, but I just want you to practice at least in making the right substitution, okay? So, what do you think is the substitution we need to make for point number 5? And what do you think is the substitution we need to make for point number 6? Remember, we want to rewrite these two problems as ay squared plus by plus c equal to 0. So, which one will be the value of y, the term of y on the first equation at the top, and which one for the second one, okay? So try to do by yourself and come back to this video. Okay, so in order to identify y, let's identify a, b, and c. c is negative 27, b is negative 6, and a is the number in front of this parenthesis, so a must be equal to 1. So y will be given by all of this term, and this is going to be y squared, right? So y is equal to m minus 10 divided by m. So that's a substitution you're going to make. For the second one, the value of c is 2. The value of b is, don't confuse with this c, okay? So that's the constant term 2. And then the value of b is negative 11, and the value of a is 5. So the y is the term next to b, so next to negative 11 in this case, so this is your y, right? And this therefore must be your y squared. Okay? So the y, the right substitution, is c to the power of 1 over 5. Okay? So once you do that, you have this equation you will write as y squared minus 6y minus 27 equals 0. Okay? You will solve for y, and once you solve for y, you get two numbers, and these two numbers, they're gonna be replaced here, where you see well, once you find the y equal the first number, y equals second number, then you replace y with m minus 10 over m, and you try to solve for m. And you will get, in this case, a quadratic equation with for m, and try to solve the quadratic equation. Here instead, for the second problem, once you, the equation becomes, in this case, 5y squared minus 11y plus 2 equal to 0, so you solve for y, you get two solution, two numbers, and then you set up these two numbers equal to c to the power of 1 over 5. You take the fifth root on both sides of that equation, and you will be able to solve for c. So that's it for this video. If you have any question, please let me know.